we will learn some statistical tools which is very much related to the machine learning and the artificial intelligence. So when your data is categorical in nature, then you can use this model. Is it visible to you?
Yes, sir.
K-Mode's cluster analysis?
Yes, sir.
Okay.
Visible.
So when we are dealing with the data, some data are numerical in nature and some data are not numerical. They are text data or categorical data. So when you will find that is your data is numerical, at that time you can use the K-means cluster analysis. Cluster means basically the grouping. Sometimes we have the idea about these are the correct groups. For example, he is male, he is female. So we know, or we can tell that is the student pass, the student fail based upon some criteria. Okay. So in that case, our learning is supervised. That means I have previous assumption that this is the classification. But when I do not have any previous information about the classification of the data, then we can follow the unsupervised clustering or unsupervised machine learning. For example, apple is circular and Rasgulla also circular. That means I cannot tell that is apple and Rasgulla is same. Based upon their morphological structure and the taste. But we can group them in one cluster that both apple and Rasgulla, they are food items. Okay, that means the clustering or the grouping, specifically in psychological research, it depends upon the cognitive structure of the individual. Now, when our data is numerical data, suppose I have collected data from the students in their examination score, math, Bengali, English, physics, chemistry, etc. Now, we can find out that is how these 5 subjects, they are related with each other and how can we classify the students based upon the groupings of these 5 subjects. This is clear now, Shoma?
Yes, sir.
Okay. So K-means cluster analysis is a popular unsupervised machine learning algorithm used to partition a data set into distinct clusters based upon their features. It's widely applied in various fields like market segmentation, image compression, and pattern recognition. Below is an overview of how K-means works, its key concepts and considerations. So randomly select K points as the initial cluster centroid. For example, you have the 5 subjects, and the 5 subjects has the mean. Again, 5 subjects has overall the mean. So mean distance from one subject to another, that can provide you the knowledge about to what extent one set of data is close to the other set of data. Assign each data point to the nearest cluster centroid. Centroid means basically the mean, based on a distance matrix like Euclidean distance. Recalculate the cluster centroids as the mean of all data points assigned to that cluster. Repeat the assignment and update steps until convergence, when cluster assignments no longer change significantly or a maximum number of iterations is reached. That means you are making the Euclidean distance between the variables. So variable 1 minus variable 2. And then its square. After that, following the rules, you have to calculate the sum of the d squares. Then you have to find out how many data are there. So you will get the mean distance. Then you can give the square root. So you will get the,
Sir, are you talking about the least square method?
it is Euclidean distance.
Okay.
Okay. So based upon that, you can find out to what extent one data is close to the another data, which usually we follow in case of the hierarchical cluster analysis. You have already taught, you have already learned the cluster analysis. So this hierarchical cluster analysis in earlier classes, uh, you have learned it. And there you have followed the Euclidean distance. Now the final cluster segments, cluster assignments and the K centroids. After that, a vector representing the center of a cluster. Determine how the closeness of a data point to a centroid measured, that is Euclidean or Manhattan distance. The user must specify k, which significantly impacts the results. This part is vital. The researcher has the idea, that is how many classification he needs. That is important part. Suppose you have very small data, then if you want 10 classifications, then you will get less number of data for each classification. Therefore, if you have the more number of data, suppose you have the 200 data and you are expecting the 5 classification, then in average it will be the 40 per group. Okay, so in that manner, you have to think, that is how many classifications you want. This is clear, Soma?
Yes, sir.
So the user must specify k, which significantly impacts the results. K-means stops iterating when centroids stabilize or when a predetermined condition is met. When K-means do not find out much differences among the variables, then it stops. Simple to implement, computationally efficient, works well for compact and well-separated clusters, and scales to large data set. When you have the large data set, then you can classify them. The algorithm requires k, which is not always straightforward to determine. Here k means how many clusters you want. Results can vary depending on the initial centroid, although techniques like k-means plus can mitigate this. K-means assume that clusters are roughly spherical and equally sized, which may not hold for all dataset. For example, you have the data and that data has some outlier. Then k-means will not be applicable. Okay. Therefore, when k-means not applicable, then you can use the k-mode clustering. K-modes follow the frequencies, but k-means follow the central tendency, specifically the mean. That means number of classification will be based upon the mean differences. But when you have the categorical data, then instead of the k-means, you can use the k-mode clustering. So now I am requesting Farah to show the k-means clustering.
Yes, sir.
In RStudio, you will find the data set. That is the IRIS data set you will find out. And now Farah will show you how the different types of flowers, they are classified into different clusters. Farah, please share.
Yes, I'm here. So, sir, this is the script. First, we have to load the data of Iris data set. I'm sir running everything in one go, and then we can explain. Just like the scattered diagram, no? Is it?
Yeah, this is the scatter plot. And here you can find out the cluster 1, cluster 2, and cluster 3. Okay. So three colors are there, red and green. They are relatively overlapping. Okay.
Yes. Whereas the
But
black is the maintaining some distance.
uh, but the black maintains distance. So this is the sepal length versus sepal width. So Farah, now you go to your script. Just you write down head bracket data, then enter. Uh, now first you write down head IDs. Enter. Okay, so this is the original data. So here you can find out the data is numerical data. Sepal length, sepal width, petal length, petal width, species also. Uh, Now what is the next command after the data? That is the, no, head IDs. After that, yeah, DF IDs, comma -5. Now you write down head bracket DF. Okay, so here you can find out that is the number fifth column that is not there. Okay, we have removed it. So iris is the data frame, box bracket, comma. This comma indicates all the rows. -5. -5 means fifth column. So in the original data, you will find that is the fifth column is Setosa, some text data is there. So that will be removed from the analysis. Next, set seed 42. After that, k-means result. Uh, then you write down only the k-means result. Okay. So this is the k-means result. So what we have noted, that is three clusters. So how many data are there total? Total how many data is there? 46, 47, 48, 49, 50. So 150 data are there. So out of 150, it has given the three clusters. So they have classified into three clusters. And for the cluster one, sepal length mean is this, sepal width is this, petal length is, petal width is this. Now you can find out that is the green, that is the cluster 3. Cluster 3, the mean is 2.07. For the petal width, sepal length 6.85 and sepal width is 3.07. 6.85 and 3.07. Now this is the clustering means, cluster means. So you will get the cluster means data. Because you have the four variables, based upon that you will get the cluster mean. After that, clustering vector. So three categories are there. One, two, three categories are there. And below, within cluster, sum of what is written. After clustering vector, what is written?
After
Yeah,
clustering
now you
vector,
will find that is the between sum of square is 23.87. Within cluster sum of square by cluster is 23.87, 39.82, 15 point something. Now between S's divided by total S's, 89.7%. That means 89.7% classification is there. So it is a good classification. That means few data, very few data, they are overlapped. Otherwise, uh, they are well separated. So based upon that, what is the next command? Print it is gone. Now the table that is also there. IDs, table IDs cluster k means result at the cluster assignment. Next is the plot. It is written plot IDs dollar sepal length and IDs dollar sepal width. It is written clearly. You go to the 81, row number 81. It is written plot IDs dollar sepal length and IDs dollar sepal width. And after that, you have done the k-means cluster. Call, call is written, call means color, color by cluster. Because three colors are there, therefore it maintains the three cluster. PCH 19 use solid circle. So here you can find out the solid circle, PCH 19. X lab sepal length, it is the X lab, and the sepal width, that is the Y lab. Main, K means clustering of IDs dataset, that means that is the title. Acha Phara, now you can write down plot
Okay, sir.
instead of sepal length, you write down other variables. Then you check what is that. What are the other variables you have? IDs dollar, petal length and petal width. Then you do the analysis. Yeah. So now here you can find out that is the, no, petal length and petal width. You have written sepal length, sepal width. Please you change. X lab you change. And next is petal width. Yeah. So here you can find out better data. So the three clusters are there, but what is the legend? Farah? Hello, Farah, you go to the console.
Yes, sir.
You go to the console. What is the legend? Yeah. Then the now it is okay. But now your legend position, that is not good. Legend position that will be below. Otherwise, we cannot find out the cluster. So cluster 3 is well separated. Cluster 2 and cluster 1. And now you go to the console again.
Yes, sir.
What is the percentage of correct classification?
Then what, sir, what are you telling, sir? Sorry, I lost my connection.
Betweenness divided by total withinness. So you write down what is your vector name. K
Sir,
means result.
yes, sir. K
You,
means
you,
result.
you write down K means result, dollar, betweenness divided by K means result dollar, total withinness. Enter. Yeah. So it will be 8.74. So this result will be into 100. 8.74 multiplied by 100. So 87%. Okay, Shobha.
Yes, sir.
Now you will get the three groups.
Yes, the separated one.
Yeah. Now in your school,
Where the black has gone, sir, I'm getting the green and red view.
uh,
And blue.
because that legend is there, no? The legend position, if we can change the legend position, legend below, then you can see the legend position. Uh, it is written top right. Uh, Instead of top right, you write down other thing that is maybe top left, but top right already there. No, top left, that is okay. Again, you have to do the same thing. Then automatically top right will be moved away.
Okay, got it, sir. Yes, visible. That.
Okay. Now the legend is visible. So you will get
Yes,
the three
now
clusters.
too many blacks and reds are overlapping.
Yeah, these two are overlapping at the higher side, but not at the lower side.
Sir, in my profession, how can I use it? Only for the result
Yeah,
or
based
any?
upon the student performance, student academic data, maybe the history, science, literature, you have to use all of them. If there is a, I think you have the 1,000 data. So then you can do the k-means clustering. Based on that, you can find out the clusters. After that, you have to draw the plot. This plot can give you the information about to what extent the groups are separated. So these are the individuals. You can identify the individual. Farah, you write down locator. Bracket 1. Then you select one variable. Yeah, only one. So now you can find out it is 2.70 in X variable and 2.50 in Y variable. So that is the coordinate. Now, if you want to identify this individual, then you can write down that is the data which is 3 in case of the petal length, and in case of the petal width, which will be more than 1.0. In this way, you can identify this particular individual. But this is the coordinate. .70, that is 3 basically, and that 2.50 in the y-axis. .70, that is very close to the 3. No? On the x-axis. Hara, again you write down locator and you click that data. Yeah. What happened? It is different
So,
data.
yes, I clicked on this. You want me to click on the same person? Okay.
Yeah, yeah.
Okay, sir. So on this side.
Uh, who is that data?
This one, this black one. This black image.
Oh, this black one.
Yes.
It is. Now this 1.40, 1.41, which is that data?
So this one is this
Oh,
light
1.4. Acha.
onion color.
1.4. X-axis. And 2.35. It is the coordinate. Shoma, do you know any idea about the how to get the data based upon the coordinate?
Based on the coordinate,
Coordinate. Based upon the coordinate, how can we get the data?
I don't have any idea in the computer. Uh,
Not the computer, just your graph. In the
so
graph, there
dropping
is
the
some coordinate,
huh.
geometric graph. The coordinate is there. So based upon the coordinate, we have to identify the particular individual.
So that is the only the if it is the axis, then
Uh,
the value, x value and y value will denote, no?
yeah, it indicates x value 1.41 and y is 2.35.
Huh?
Now, if you follow the x value, x is the petal length and 2.35 that is the petal width, but that is a different thing. That is the coordinate.
What do you are
I want
asking?
to find out this particular individual. Farah, again you click which individual, please you click.
Okay, sir. So
Yes.
black one or the onion color? So black one,
Onion, onion.
onion. Okay, okay, sir. This.
Yes, this particular case, it is 1.40 in case of the X, and in case of the Y, it is 2.34. This is the coordinate.
Are you asking for the regression data or like this equation?
No, no, I'm not talking. I want to know that is who is this individual.
Okay.
So, sir, we have to check the petal width wala data, no? Fill then. Erase. Come like this. What is the name? Iris pet. Okay. We can find the individuals here, but how?
It is based upon the petal,
Yes, sir.
petal length 3, and petal width will be the 1.0.
Hmm.
What is your 3? Okay, we have to find out later on.
Yes, sir.
But this is the 3 clusters. And if you want to find out the specific data, that can be done by some other analysis.
Sir, I'm getting that Fisher data, something like that.
No, it is not the
Answer.
regression data. It is the clustering. And now if I want to find out that is which is this individual whose petal width is 1.0 and petal length is 3. So Farah, you write down Irish dollar petal length equal to, no, no, equal to, uh, equal to, double equal to 3. Then enter. Is there any true? Yeah, 97, 98, 99. 99 number cases. Now you find out this 99 case in above. Yes, 3. That is the 99 in case of the petal length. And this case in petal width. Petal width you have the above. Go to the petal width 2.5. No, it is not like that. It is not typical regression model. It is written 1.0. That is the 1.01 or 04. Is there any 1.4? Hmm. Is there any 1.4 in case of the petal width? Petal length 3, we got it. But in case of the
One.
petal width,
Yes, sir. Mm, mm, mm.
you write down range,
Okay.
bracket petal width. Range bracket iris, dollar, petal width. What is the
Enter.
range? Enter. It 0.1 is there. That means data is there.
Yes, sir.
So yeah, you write down petal width, iris dollar, petal width equal to not the equal to. It is the uh, greater than 1.0, greater than sign, 1.0 and ampersand
Sir, after क्या sir 1.0?
and
अच्छा. Sir, this one.
uh, and iris dollar petal width less than 1.5. Then enter.
Two. So 56. 56. He's asking to check.
Is it in 99?
99. Yes, sir. 99 is also there.
Okay. That means that is the data. Okay, Shoma, you got it.
No, sir.
In this manner, we have to find out.
Achha. So that means there exists, that point exists or not. So we
Yeah,
are going to
yeah,
search for it.
that point exists basically. So we have to write down in this manner.
Okay.
Farah, please you share. No, no, not that one. The last one,
Acha.
last formula, last
That
bit.
greater than or less than that petal length and that thing.
Yeah, yeah, yeah.
Mm-hmm.
So if you write down greater than 1.0 and less than 1.5, then you
Ha
can identify.
Okay. What is the position that will show?
Yeah, yeah. And how many people are there, that is also possible.
Okay.
That is how many people are greater than 1.0 and less than 1.5, that is possible.
Okay.
Para, you write down uh, table, bracket, whatever the things you have written earlier, id is dollar, table, bracket. Yeah, whole things will be in bracket. So at least 29 data are there.
Oh,
So if you want to find out how many people are there, that is also possible.
acha, counting that will be given.
Yeah, yeah. It is the frequency.
Okay.
So that is possible.
Bapre, sir.
That is possible because of the art studio. If you know the art script, then you can do this.
Much more practice is needed. But
Okay, now it is clear.
yes, sir.
So you have understood the beauty of the k-means clustering.
Hmm.
You can apply the k-means clustering in your school data. So may I close now?
Okay, sir.